Well, hello, and welcome to part 3 of the notes on the unit on energy. And in this particular part, we're going to focus on the difference between renewable and non-renewable energy. I wouldn't be surprised if this was something you heard of before, and I know it's going to be something you'll hear of in the future, because this is an important conversation for our country, the world, and just each individual to decide, what are we going to do about energy? Sometimes you hear it referred to as the energy crisis. And a lot of that has to do with using renewable versus non-renewable energy. So first, let's describe the difference between those two. And there's different ways to define this. So don't take this as like a dictionary definition, but just sort of a rule of thumb to use. So this refers to how long it takes to replenish. Okay, so if we want to categorize an energy source as either renewable or non-renewable, if we say it's non-renewable, whoops, helps if I spell it right. Usually this means it cannot be replaced in a generation or the average person's lifetime. So how long would that be? Well, I don't know. You want to maybe say 80 years or something like that. So if it's a resource that we cannot replace within maybe 80 years or so, or we might use maybe 100 as a rough guideline there, then we consider it non-renewable. For example, most probably common example is coal. We dig coal out of the ground. That coal was formed millions of years ago from the decaying matter of animals and plants from millions of years ago. So, of course, we still have plants and animals that are decaying after they die and they get buried in the ground. So in millions of years, we'll be able to use that material because it, under the forces of the Earth's heat and pressure, it will form coal again. But that's certainly not within a generation. So we're good a million years or millions of years from now, but we're not very good right now getting coal. So once we use up the available coal or other, what we refer to as fossil fuels, then there's going to be no more. So then renewable is just the opposite. So we can replenish, and replenish is not always the right word. I'll describe what I mean here. But if it'll be available to use again within a generation, then we'll call it renewable. So again, a really easy example is like the sun. We get a lot of solar energy that we can use to produce maybe heat. Some people can heat their homes with it, and also electricity if you use solar panels. So the sun, if you use it today, it's going to be back tomorrow, and you'll be able to use that energy again. So that's certainly renewable. And we'll go through a few other examples of these renewable energy sources later. So there are advantages and disadvantages to each one. So you might think, oh, well, let's just always use renewable. And the two main advantages, of course, are, we'll say it's plentiful, so we won't really run out, so to speak. But besides that, these energy sources, when we use them, also tend to be cleaner. And I'll use that in quotes. That just means less pollution in the process of turning it into something useful for us. Usually that's electricity that we use. But that could also mean things like when we use renewable energy sources for our cars, there might be less exhaust, okay, and that sort of pollution. But there are advantages to non-renewable as well, and these would be kind of considered disadvantages for the renewable energy sources. These tend to be higher cost. Oh, I beg your pardon. The non-renewable energy sources, we would say, I just forgot how I made that statement. These are lower cost. So using fossil fuels to produce our electricity is actually less expensive. Using gasoline to power our cars, that technology is less expensive. Because we've been using it so long, we don't need to invent new things, okay? Because it's a older technology. Now, we are still refining the gasoline engine and trying to make it more efficient. We're still making cars lighter, but the process of burning gasoline, we've known about that for over a century. But the idea of burning, for example, ethanol, or using other biomass fuels or things like that, even the new electric cars, that's relatively new technology, and we're getting better all the time, but those, you still pay a premium if you want to use those technologies. What's the other advantage to using a non-renewable? Well, generally speaking, they're available everywhere. But let me describe, for example, why this wouldn't apply to renewable energy sources. Most renewable energy sources, and I'm going to go over my space here, so I'm going to call them location specific. That means they're only available in certain places. So if we want to use solar energy, well, that's not going to work very well in Seattle, where it's cloudy a lot of the time, or in England, where they're known for, clouds almost every day. It might work great in the desert. And if you want to use hydroelectric power, that's not going to work very well here in, Dayton, Ohio, because we don't have a big river where we could extract the energy. It might work well if you live near, the Mississippi. And so, or we'd have to build a big dam like they did out in Nevada and many other places. So, if you're not in the right spot, it might not be very easy to use some of these renewable energy sources. But we can always ship coal down on a barge down a river like we do. We take it maybe from West Virginia, ship it down the Ohio River, settles down in near Cincinnati. We got some power plants down there. We burn the coal, we generate the electricity, and then the wires can carry it anywhere we need to. So we could certainly carry the electricity on wires from other places, but it's just a little bit more complicated with some of the renewable energy sources. So now we're going to look at specifically a few of these non-renewable versus renewable energy sources. All right, so a lot of these have a lot in common. 3 of the 4 have something in common. So let's start with kind of the one outlier. And it's uranium. It's an element which can undergo a nuclear reaction. This is not a chemical reaction. The other elements are going to undergo a chemical reaction. This is a nuclear reaction to release lots of energy. And this is what we refer to as nuclear energy, or you may have heard of a nuclear power plant. The fuel for a nuclear power plant is uranium. And it's an ore. We dig it out of the ground and we extract it. It's just a special kind of ore that actually goes through what's called a nuclear decay. And that means it's changing into other elements. It's a very unusual process. Most elements you're familiar with wouldn't be doing that. But it is not renewable. Once we dig it out of the ground, we're not going to have it again for a long time, because for that to form, that happened early in the kind of the lifetime of the Earth. And so we're going to be out of it when we use all that. Now, we've got plenty left. We don't use a lot of it because nuclear power has some dangers associated with it, but it is still considered a non-renewable source. And these other 3 are all referred to as fossil fuels. The idea of a fossil is millions or billions of years ago, living matter like animals and plants died, got into the ground, got covered up, started decaying, and then the heat and the pressure of the Earth being underneath all that stuff turns it into these different kinds of fossil fuels. So one that I'm sure you've heard of is coal, which is a solid that is mined, dug out of caves or holes in the earth. Whoops. And like all fossil fuels, can be burned to release energy. And this is, for us locally, a common source of energy because it is around. It's in West Virginia, it's in Ohio and Pennsylvania, and you hear these what they call the Rust Belt. Sometimes that refers to places where coal was so plentiful that there were a lot of manufacturing plants and factories, and a lot of those have closed down. But that's because of the plentiful coal around here. And then we have natural gas and oil. And these can be burned in different ways, but it's the exact same idea, except that this is, as its name implies, it's a gas, and this is a liquid. The oil goes through a process we call being refined into many different fuels. So gasoline is one of the things we get from oil, as is kerosene, butane, you might have heard of, like small butane lighters, propane, like for the propane tanks you use on a grill or for a torch. So all of those different kinds of fuels come from oil. And natural gas is something that kind of exists. There's big pockets of it down in the earth, and around here it's often burned. Oops. When I try to talk and write at the same time, it gets my brain can't do two things at once. I'm old, I guess. I know at my home, that's what we burn for our heat. So you have a natural gas furnace. You may have an older home where you're burning oil. There are oil burning places out in the east. They have a lot of oil burning furnaces. You're not going to find coal anymore that I know of. It used to be around here, maybe back in the 1950s. There were a lot of homes with coal burning furnaces. So there's an example of some non-renewable, and again, these last three are all considered fossil fuels because they get extracted from the decayed living matter from long, long ago that has now turned into a source of fuel for us. So now let's take a look at these renewable resources. And there are 5 of them that I chose, and there's some others that we could include in here, but these are the ones you've probably heard of before too. Hydroelectric, this just means harnessing energy in rivers. We did this way back in the 1800s using a water wheel. That's why they would build factories right next to the river. But now we can build a big dam, and as the water goes over the dam, we make it go through certain locations, and then we get the turbines moving, and that can generate electricity. Solar, or sunlight, as you would probably more likely call it, can be 2 things you can do with this. Using solar panels, extracted is not the right word there. Nah. Converted is a better word. Converted by solar panels into electricity. But you can also, if you have solar panels, you can use it to heat water. So people can heat their homes with this. And in areas where you get a lot of sun, but it's still relatively cool, so that might be, I don't know, high up in the mountains, and there's little cloud cover, this would be a great way for both heating water, and therefore your homes, you can use that hot water to heat your home, or to generate electricity. And I know some people who actually have these on their rooftops here in Ohio, and they're what we call off the grid. They don't need to use the power from the power company. Geothermal. Not very commonly used. I've seen stories of it in some places. This is a better time to use the word extracting. Extracting heat from underground. You might be surprised to know this, but you don't have to go too far under the ground to find that everything under there is roughly 55 degrees Fahrenheit, which around here is warm for the winter months. So if we can extract some of that energy from down there, and it's warmer than what it is up here on the surface, then we could maybe perhaps, well, what we do is we run tubes or pipes of a liquid. So we bury these pipes deep down into the ground, and you can bury them horizontally or vertically depending on how much space you have. And when you run some liquid through those pipes, when it runs long enough through the warmer parts of the ground, it will extract the heat. We call that a heat exchange. So the heat from the ground will go into that liquid, and then you can pump it back into your house, and if it's warmer than the water that's already in your house, you can warm up the water with that, and then you can heat up your house. So geothermal, kind of a neat idea. It's very expensive to do that, though, which is why it's not very common. All right, biomass, fancy sounding word, but it's actually something you know. These are just plants for which we can extract some type of fuels. Examples, the most common is just wood. If you have like a wood burning fireplace, that's biomass. But we can also go through a chemical process with corn where we extract ethanol from that. And there's a little bit of ethanol and a lot of gasoline that we get at the gas station. And there are some cars that burn straight ethanol. And there's some plants where we can actually burn ethanol to generate electricity. And anytime you burn anything that's living matter, that would be considered biomass. And the fifth one is wind energy. So with wind energy is just as the name implies. We use the natural movement of air And why is there wind? Well, it's because of a difference in temperatures. So if we got one part of the atmosphere that's at one temperature and a part that's a different temperature, we naturally get these convection currents. I'll maybe add that in here. So it's caused by temperature differences. And you know this just from your experience with weather. You know, when do we get a lot of wind? It's when we have maybe a warm front somewhere and a cold front somewhere, and that hot air and that cold air, when they start mixing together, there's a lot of rushing air because energy likes to move from where there's a lot of it to where there's a little bit of it. And so that's just what we call wind. So the natural movement of the air, and it's just used to move. We call it a turbine. So you've seen the big wind turbines probably on the highway. There's a lot of them in Indiana right now, up in northern Ohio. But occasionally you'll see one other places. And if we turn a big propeller, and inside that propeller we've got something that can create electricity, then we've got a little bit of an electricity source just from the natural movement of the wind. There's a lot of drawbacks to those as well. People don't like the appearance of them. They're kind of big and unsightly. So you tend to find them places where people don't live, next to highways and things like that. But they certainly are. They're showing some promise in paying off. They're expensive to build, but if you wait long enough and you don't have to do a lot of maintenance, you can find that your investment in building it pays off in not having to use power from the electric company. So, all right. So there's some examples, and you again may be familiar with one or two other ones that you've heard of before. But if you understand the basics of these, I think that'll be good. So we'll do a little bit more with renewable and non-renewable energy sources, and hopefully you'll understand those a little bit better after those activities.